How can you build asynchronous REST APIs? This is an API that allows you to send a request, immediately get a response back, while the work is being performed in the background asynchronously. After a given time, you can check a status endpoint to see if the work was done and obtain the result of the processing. I always prefer explaining concepts like this with an example, so let's look at a post endpoint that allows us to send an image, let's call it a thumbnail, and we're going to resize the image into a couple of different sizes. And what this endpoint is going to do is it's going to resize the original image into a couple of different sizes. So if I send a request, I'll get a response back pretty quickly, which contains the identifier of this file that I uploaded to my server. I'm using a form data request to send this file, and I'm getting back a response that contains a set of HateOS links that I can use to access the individual thumbnails. Each thumbnail has a different width. So let's say I choose this one, which is 256 pixels wide, and I send this request. I'm going to get back the thumbnail in this resolution. If I wanted something smaller, let's say 128 pixels, I'm going to take this endpoint, and if I send this request, you will see that we get the same image in a different size. So this is how the thumbnail generation works. Now I'm going to enable the breakpoint on the backend and send the request again so that we can actually see what is going on. So we have a thumbnails controller which exposes two endpoints or actions. One is called upload image, and it accepts a form file. And this is how we're actually going to upload the original image and then generate the thumbnails. So we're going to generate a random name for the folder or the identifier of this image, and we're going to create this in the uploads directory. This is configurable through application settings. And then we're going to use the image service, which is just going to validate that this is an image. And you can see the validation logic above. It's just checking that this has a valid extension and it's also a valid MIME type. I hard-coded these values for the purpose of our demo, but you can also make this configurable through environment variables. Then what's going on, we're going to create a directory to hold this image, and we're going to save the file on our local file system. So now we're going to go back into the controller action, and the next method here is generating the thumbnails. So if we go inside, what's going to happen is for the available thumbnail widths, which I also have hard-coded, so all of the widths are a power of 2, 32, 64, 128, and so on. We're going to iterate through all of these, and for each one of them, we're going to create a thumbnail, and I'm using the image sharp library to implement the resizing. So this is all the code that's required to resize an image into a specific width while maintaining the aspect ratio. So I'm going to continue to this line here. And let's go ahead and generate the links, which uses a helper method here. And what's happening here is I'm using the link generator to create a URI for a specific action. So this is how the logic works. So if I hit continue, we're going to get back the response in Postman. Now let's go ahead and make things more interesting by actually simulating some processing going on in the background. And the simplest way to achieve this is to add a delay inside of each of our processing steps. So let's say I want to add a 5,000 millisecond delay after generating each thumbnail. In our case, this is just an example, but in a real-world system, you can imagine how we could have concurrent requests all performing some sort of processing, and all of this processing could end up being heavy on the CPU and the server resources, which is going to impact our response time. So now if I start the application and I go ahead and send a request to my API, you will see that we are going to wait and wait and wait until the processing time expires and we get back a response containing our thumbnails. Now you can see how this isn't a really good user experience. Imagine if this was a client-side application, you click a button and then you have to wait for 25, 30 seconds, a minute, or however long it takes to process this request. So this is where asynchronous APIs come in, and now I'm going to show you how we're going to refactor this to be an asynchronous API, which is going to drastically improve the user experience. So we get a response back after 30 seconds, and the response contents are the same, but we want to focus on improving the implementation to make it asynchronous. So the expensive part inside of our endpoint is this line here that's responsible for generating the thumbnails. So in order to make this asynchronous, we have to move this work into the background using a background job or something similar. Now .NET has an excellent abstraction for this, which is called a channel. And let me show you how we can use it. So a channel is like a pipe where you can send your messages. You have the writer on one end where you can write a message, and then you have a reader on the other end consuming these messages. So you can call the channel class, and it has a couple of helper methods that you can use to create a channel. You can pick between a bounded channel and an unbounded channel. An unbounded channel doesn't have a limit in the number of writers or readers, and it can also contain any number of messages. So I'm just going to pick object here because it's the simplest one, and I want to show you the API of the channel type. So we have a reader and a writer property. A writer allows us to write a message, so I can say try write and instantiate a new object that I'm going to send into this channel. And what's really cool is that this is asynchronous. So we could have a reader in a separate thread using the respective channel reader to read a message. For example, I can call try read, and I can get back a message that was written into the channel. So this is the mechanism that we are going to employ to implement async processing. Now I'm going to get rid of this, and we need to put in place a few more things. So I'm going to create a helper folder that's going to contain some types, and I'm going to add a new class that I'm going to call a thumbnail generation job. This is actually going to be a simple positional record, and it's going to contain the ID of the thumbnails that we want to generate. It's going to contain the original file path for the main image that we're going to store locally, and it's also going to contain the folder path where I'm going to store the thumbnails. Now, based on the thumbnail generation job, we're going to create a channel. So what you can do is actually register a channel with dependency injection. So I can say builder services add singleton, and here I can create a channel and return it to register it as a singleton service. So I want to say channel create bounded, and I'll specify my message type, which is the thumbnail generation job. So let me add the using statement, and this will allow me to create a bounded channel, which means I can control the number of messages that can enter the channel at any given point in time. You can either provide the capacity directly, or you can specify the bounded channel options, where you can also provide the capacity. But what I wanted to do with the options is be able to set a few more values, and one of those is the full mode property. So this is an enum called bounded channel full mode that allows me to configure what's going to happen when the channel is full. So you can either drop the newest or oldest message, drop the current write, or you can tell the channel to wait. And I'm going to employ this option. So what's going to happen this time is when we attempt to write to the channel and it's full because it's bounded to 100 messages, we're going to force the writer to wait, or block in other words, until we are able to write into the channel. So this is going to give us natural backrusher protection on the upload endpoint so that we don't overwhelm the server with too many thumbnail generation job messages. One more thing that's going to be helpful is to be able to track the status of a thumbnail generation job. So I'm going to add another type into this folder, and I'm going to call this a thumbnail generation status. And this is going to be an enum. So the values are going to be queued, processing, when we are asynchronously processing the job, then we're going to have completed, and failed if we run into a problem. Now, having a thumbnail generation status implies that we will have to somehow persist this. You could use a proper database, an in-memory cache like Redis. What I'm going to do is a very simple approach. I'm going to say builder services add singleton, and I'm going to add a concurrent dictionary where the key is a string and it's going to match my folder ID, and the value is a thumbnail generation job status. So this is just a bare bones approach, and in a real world scenario, you will probably want to persist this in a file system rather than in memory, which is what a concurrent dictionary does. But now let's see how these two abstractions are going to allow us to make our API endpoint asynchronous. So I have to start by injecting these services inside of my controller. So the first is a channel where the message type is a thumbnail generation job. Then I'm going to inject a concurrent dictionary with a string key type, and the value is a thumbnail generation job status. So let's call this a status dictionary. So now let's focus on the upload image endpoint. I'm going to rename the folder name into ID to make it more obvious that this refers to the identifier that we are generating for the uploaded image. Now, this is the part of the code that we want to move into the background. So I'm just going to comment this out. So now, instead of generating a thumbnail, we're going to create a thumbnail generation job. We need the ID, we need the original file path, and we need the folder path. All of these values we already have. Then we're going to use the channel, access the writer property, and we're going to say write async. And I'm just going to specify the job, which is the message that I'm writing into the channel. Because we set the full mode to wait, we're going to block on this line of code if the channel is full. If this succeeds, then I want to update the status dictionary for the key representing the identifier of my image to queued. So we successfully added the thumbnail generation job into our background processing. And now the most correct thing to do is to return a 202 accepted response. This is the status code that your API should return when you have async processing in the background. Because we can no longer return the links, I'm going to return a status, and we're going to return a thumbnail generation status of queued, which is the same value that we set in the status dictionary. However, a 202 accepted response should also return a location header that allows you to send a request to find out what is the status of the background processing. So we don't have an endpoint like this just yet, so I'm going to create one. And let's make the route contain the identifier, and then let's append status. So I'm going to say public action result get status, and we're going to accept an identifier. So this is the endpoint that I'm going to use to generate my status URL. So I'm going to call the get fully qualified URL method. We're going to say name of get status, and the route values are just going to contain the ID. And then I can specify this as an argument here when I'm returning the 202 accepted result. Now let's get rid of the commented out code, and let's see what we have to put in place in the get status endpoint. The first thing I can do is check if the status dictionary contains the value with this ID. So I can specify the ID, and I can get back the status of my thumbnail generation job. So if we can get this value, we're going to return not found. Otherwise, I'm going to construct a response, and this is going to be an anonymous object, where I'm going to specify the ID of our job, then I'm going to specify the status, and I'm going to create a links property or value, which is going to be just an empty dictionary containing a string key and a string value. And then I can go ahead and return this from my endpoint. Now, what about the links dictionary? So what I want to do here is check if the status is equal to thumbnail generation status of completed. And in that case, it means that our background processing is done and we can return the HateOS links pointing to the individual thumbnails. So I'm going to get the thumbnail links by using the image service type, where I have a set of thumbnail widths, and I'm just going to call toDictionary, where the key is going to be the width itself. So I'm going to specify W and then the width value, and then the value of our dictionary elements is going to be a URL pointing to the get image endpoint, and the route values are going to be the ID and the width. We're also going to add another value to this dictionary, which is going to point to the original image, and this is just going to use the action name, so get image, and then the route value is going to be the ID without a width. And then I'm going to do something pretty cool. I don't know if you knew that you could do this with anonymous types, but anonymous types support non-destructive mutation. So I can say response with and just update the links values. And I'm going to provide the thumbnail links. And if the status is completed, we're going to generate the links here and return that as the response. This would be even more awesome if I didn't have to generate the links beforehand, but if you do this, then you can do non-destructive mutation because it doesn't know that the links property exists on the anonymous type. So this covers the API service. Now, what about the background processing? Well, for this, we need some sort of background worker, and the simplest way to implement this is to create a background service. So I'm going to go ahead and do that. I'm going to call this the thumbnail generation service. And let me inject a few services to implement this. I'm going to use a logger to write some statements. I'll need the image service to actually generate the thumbnails. We'll need our channel so that we can asynchronously read messages from it. And remember that we are writing these messages inside of our controller endpoint. And I'll also need my concurrent dictionary. And one more thing I will need is a concurrent dictionary so that I can update the thumbnail generation status. So let's call this the status dictionary. So how do we implement this? Well, the reader on a channel has a read all async method. and this returns an iAsync enumerable, which is going to allow us to asynchronously read from this collection. So let me show you how this works. So I have to specify a wait for each here, and every time we write something to the channel, we're going to iterate inside of this for each loop, giving us the thumbnail generation job. Inside of the for each loop, I want to have a try-catch statement. In case of an unhandled exception, we're just going to write an error log. So I'm going to say logger log error, specify the exception, and I'm going to say error processing thumbnail generation job. It could also be useful to handle some exceptions like an operation canceled exception. This happens when the cancellation token triggers, and let's say in this case I just want to break. Now what happens here? This is where we actually generate our thumbnails. So I'm going to create a helper method called process job async. Is going to accept a thumbnail generation job, and this is where I'm going to implement the logic. And inside of my for each loop, I'm just going to await this method and pass in the job instance. And then inside of this method, we're going to start by updating the status dictionary using the job ID. And now we're going to say that we are processing this specific job. Then let's add a try-catch statement. And inside of the try statement, I'm going to use the image service to generate the thumbnails. I already have the original file path, the folder path, and I'm also going to pass in the file name, which is our identifier. After we complete this, we're going to update the status dictionary to be completed. And if we run into an exception, we're going to update the status dictionary for the same value to say that we failed to process this job. And let's say I just rethrow the exception because I don't know how to handle this. So now I just have to add my background service as a hosted service inside of my program CS file, and I can go ahead and start the application and show you how the asynchronous version works. So now if we send a post request to our endpoint, we're going to immediately get a response back. The response body is going to contain the ID of our image, which is randomly generated on the backend, and the status is 0, which means that the job is queued. Now, if you take a look at the headers, you will notice that there is a location header pointing to the status endpoint. If I go ahead and send a request to this endpoint, we will get the current status of the job, which is 1, and this is equal to processing. So our background processing is running in the background, and after some time, when I resend the request, the processing is going to complete. The status is updated to 2, and we also get back a set of links containing the thumbnail URI. So now I can pick a URI, let's go with a slightly larger size, and if I send this request, I get back the thumbnail. So now our complete flow is completely asynchronous, but let me show you what happens when we send a request. So I'm going to send the post request again, and we're going to land on the breakpoint inside of the upload image endpoint. So here, we're going to just store the original file, and let's say that this is a fast operation, and this is the only work that we are going to do inside of this method call. So now I'm going to write a thumbnail generation job into our channel, and mind you that this could be any kind of async processing flow. You could use Hangfire to schedule a background job. You could write a message to the database, which you could pull from a background job, similar to how we implement an outbox. So keep in mind that what I'm explaining here is the concept of building asynchronous APIs. As soon as I go over this endpoint, I'm going to land on the breakpoint in my background job, and now you'll see I'll go back and forth because I have concurrent threads. So while I'm attempting to return the result from my endpoint, in parallel I'm also going through the background job. So after a few more steps, we're going to return a response to Postman, and in the background we're going to process the background job to generate the thumbnails. So now I'm in the background job, I'm generating the thumbnails, and this takes a while, and in the meantime we land back inside of Postman. So now I can again use the location header to obtain the URI, where I can pull for the status of the background job, which you can see is here. So the processing is going on in the background, and after a few more seconds or minutes, it really depends on how complex your background processing is, the status is going to update, which you can see here. Because we land on the respective breakpoint, I'm going to update the status, and I'm going to hit continue. And now when I send the request again, the status is updated to completed, and I have my links pointing to the individual thumbnails. So this is how you can implement an asynchronous REST API endpoint using channels. Now, mind you that channels only work in memory. So this isn't going to work in a distributed environment if you scale out your application, but it is going to work inside of one process. If you need to scale out, you can use Redis as the messaging component. You could replace this with Hangfire and scheduling Hangfire jobs in the background. That's another alternative. Or you could implement your custom custom solution with writing to some persistent store like a database and then pulling from that database to process the individual jobs. But the overall idea here is immediately returning the response to the caller with a 202 accepted status code and also setting a location header where they can poll for the resource when the processing completes. And if you want to see how to implement asynchronous APIs where you update the caller using SignalR and WebSockets, then you should watch this video next. Check out my courses to improve your .NET and software architecture skills, and until next time, stay awesome.